Hello everyone and welcome back to Stationeers. Okay then, now in this episode I would like to do a couple of things. The first thing I want to do is to automate the counting of the printers. I have finally managed to put a script together that should be working quite alright, so for that one I will print out, I believe we only need a couple of logic dials, I believe. So we will need, sorry, that's the pipe bender, electric printer. So we will need a couple of logic switches. I believe these are the ones that will have the dials. So we need gold and what was the other one? Copper. Okay, so gold and copper. There you are. Hopefully this will be fine. So all of you go in and we need 4 of them. I don't think I will set one up for the tool printers. I will have one for the rocket printer and one for everything else. So I think that should be fine. So there is 1 and we need 3 more. Okay, so that's going to be the last one. And I suppose we might as well start cabling things up. So we will need the cabling, and I think I will put these dials right here in the back, like there. Yeah, I think that will do all right. They will be easily accessible, and we just need to set the number on them, and they should output the required number of items. There. I will first take care of the cabling, and then we will take care of the rest. Okay, cabling is supposedly finished. Now we just need to hook up these guys and... Alright, and we also need one housing. Housing, just one of these. So steel and solder. And solder is this one. But we still need a bit of steel. And the silver, yeah. There you are. So we need one of these as well. Other than that, we are good to go. Obviously, we have these extra IC10 chips, so we have these at the ready, so that's great. Okay, so let's just output the dials and set them up. So these guys will go right here and like so. Unfortunately, in this configuration, technically speaking, they will be upside down, so we will have to add on this side, subtract on this side, which is not the best, but whatever, it will do the job. So there, there, and there. Also, we might as well set the maximum amounts that we can set on these. I think I'll just set these to the maximum, so that will do. I believe the maximum is 1000, so there. There we go. So now they are set to the maximum. And we also need to make sure that they are named correctly. For that one, I will copy the name of the respective printer and simply overwrite it, because they will use the same name. I will try to explain how the code works once we get to it, but basically the dial and the printer will be named the same. So there, and the auto lathe, just copy the name, thank you, and there we go. Okay, so we can set these as much as we want, that's great. And now we need to take care of the code itself. I suppose we can have the code right next to the, whatchamacallit, the transformer. Let's take out the code. So, as you might have guessed, I have already written it. Let's just go ahead and load it. Printer counter is no longer work in progress. It will do exactly what we need. So, load the code, overwrite, and close and pause. Now, technically speaking, I could make it so that we can read the dials on the stackers. All we need to do is change this one, and then we can basically read the dials or the valves on the stackers, and that will do exactly the same thing. But you know what? It's fine. I don't really want to do that. This will do just fine. So anyways, let me just quickly override the code. So export, chip, export, in you go, and you can turn on, and we can put back the plastic sheets there. Nice hidden, that's fine. And let's just test it before I explain it. So let's say we want to have cables, and let's say we want to have 6 even numbers, so we don't have half grams. So print out 6 cables, please. 1, 2, 3, 4, 5, and 6, and it stops. Very good. And we get output, and we have 6 cables. Lovely. And it reset to 0 exactly. Good. Okay then, let me see if I can explain it. Open, edit, and pause. So at the start we are setting up the different registers so the code is as readable as possible. And then we have a section where we are going to load the name of the printers, which is basically the same as the name of the dial. And we are loading the hash code for the printer itself. We don't need to load the hash code for the dials because that is going to be the same for every single one of these. This way we can save a little bit on the lines. This is basically just a cost-saving measure. If we name the dials and the printer the same, we don't have to, load the dial names as well. Anyways, after we load for example, the name of the electrics printer and their respective hash code, then we jump to the print section of the code right here. After that, we will jump back to the original line, load the next one along with the code, and run through the code once again. And in here, first, we load whether or not the printer is active. We only want to, let the printers go manually. So we check whether or not they are active. If they are active, then the printer wipe will be set to 0. Otherwise, if the printers are not active, then we are actively wiping their counters. If they're active, we stop wiping it for obvious reasons. Now, if the printers are active, then we will run through this section of the code, but if they are inactive, we will skip it. It's absolutely not needed. So, if they're active, then we will load the setting from the dial, the export count from the printer. If the export count is less than the dial setting, so the target, then we will keep the printer active with the printer active register, and we will also invert this into the printer wipe. So if the printer active is 1, then the printer wipe will be 0. We don't want to wipe it if the printer is active. But if the printer is inactive, then we wipe the memory. But I suppose it does the same as this one, but I just want to be extra sure. And then we wipe the memory with the printer wipe. If it is 0, obviously we will not wipe it. And we will keep the printer active or inactive with this line. And if the printer wipe is set to 1, so basically if we have deactivated the printer and wiped the memory, we will also wipe the setting on the dial. And then we jump back to the start, or not the start, but the original line, and load the next device. And once we run through the entire thing, then we jump back to the start. So hopefully it is self-explanatory. As I've said, I don't think this is, although wait, it is necessary because we are checking here. Okay, technically speaking, we could do this a bit more elegantly, but you know what, it's fine, it will do the job. And I did say that we can change these lines to use the stacker codes. So as I said, we could use the stackers as well, but for this one it's fine. And we could also, we are batch loading from the printers. So technically speaking, we are importing their export counters as a sum. So if we have more than one printer of the same type and the same name, then we could add their counter numbers together. And for example, we could have multiple electric printers all churning out the same. Obviously we had to set them manually to print out the same thing, but we could have all of them printing out keyboard, and as soon as the added counter reaches the target number, then everything will be shut off. At least theoretically. I have not tested this, but I know with the single printers this works. So there we go. Hopefully this will make sense. I guess we will see. Now, next up, with this one taken care of, I would like to set up a monitoring console for the water generator. Right. By the way, how much water do we have right now? We have nothing yet. Okay, that's fine. Didn't I? So you are working right now. I think so. Right? Yeah, we have 5 liters, it is being cooled. Okay, it's working. Now, we need to do a couple of changes before we get to the monitoring station. We need to have one cable analyzer. So you, one cable analyzer, please. Iron and silicon. Let me see. Iron. Just put out everything and let's see. There you are. So iron and silicon for one cable analyzer. Iron, please. Thank you. One of these. And then we will need, I suppose, yeah, a couple of housings as well. So might as well. Oh, right. I almost forgot. We need to have one of these. So one cable analyzer. After that one, we need 3 housings. So right, this one is finished. We need 3 housings. So housing, you know what, let's start with a single IC10 chip. IC10. This one requires electron, there you are. One of these. And then we will need housings. After this printing is done, I will print it out. Right, we will need these obviously. That's fine. Unfortunately, I could not manage to put the monitoring station into a single housing. It is simply too complex, or okay, not complex, but it is simply too big. Anyways, we have the 3 chips, we have the cable analyzer, now we need the 3 housings, so 3 housings, please. And while that one is going, we can take care of the other analyzers. We will need 1 liquid and 1 more gas analyzer. So, analyzer, we need 1 liquid, iron, gold, electron. Electron, iron, and the gold is in that one. Well, what about the gas analyzer? Yeah, the same, we need the gold. Okay, fine. This is now only 1. I really should have brought in a bit more gold. Oh well. So we need 1 of these. I suppose I will quickly install the cable analyzer. You will go right here. That will do. And I do believe I need to name this one, although I'm not 100% sure, but let's make sure. So this is going to be CA cable analyzer. Don't worry, the code will be a bit more readable than the cooling setup, but still. Anyways, we have the 3 housings, good. Now give me the code, please. So give me one of these and a, right. I keep forgetting now we are using these. So one analyzer and another one, but liquid, please. Oh wait, didn't I have an extra? No, I didn't. Okay, whatever, it's fine. So let me see. I believe the gas analyzer will go on the oxygen line. So that will do. And right, we need one more insulated liquid pipe. I mean, technically speaking, it doesn't have to be insulated, but you know what? Just keep it insulated, it's fine. So this one will be monitoring the base water mounts. Okay then, yeah, might as well pick up these cables there. And I believe we are good to go. Okay, now housings, we have them, we have the chips. Right, first things first. I want to adjust something on this guy. Technically speaking, it is working quite alright, but it could be working a bit better. So quickly go inside, don't vent too much hot stuff into the base. There. And you first turn off. You go in here, import. It's not really needed, but might as well. And I want to load the combustor code. I have changed a couple of very small things. So let me see. Before, the oxygen mixer was running continuously if the oxygen tank was completely empty. Basically, I have added the O2 analyzer. Might as well name the gas analyzer accordingly. So this is going to be the O2 analyzer. There we go. You can turn on, by the way. So we will only run the oxygen input pump if we have any kind of oxygen on the input side, basically. Otherwise, don't bother. Don't waste any power on that. And we will only input gases into the the combustor if we have any kind of oxygen on the input as well. So it will check the voltage ratios, but it is only checking if it is above a certain number. If it is 100%, it will count it as valid, but if we include an oxygen check as well, it will only run if we have oxygen too. So, you know, if we only have voltage, if we have run out of oxygen, it will not run. Yeah, that's great. And also I have lowered the threshold for the combustor to 1 liter. So I suppose if we only have 1 liter on the water cooler tank, then it will be a bit more efficient, I think. So we only have to cool down 1 liter. If it's down to temperature, it will get shoved into the base. I've also lowered the temperature threshold to 30 degrees Celsius. So, you know, now that we have to cool down less, I suppose we should be a bit more efficient. So that should do it. And water analyzer, we are now reading the the tank through this one. So this one is going to be the water analyzer. That's correct, because now we have 2 liquid analyzers, so we need to differentiate between them. So you should be fine now. Yeah. Wait. Export, and then you can go in there and you can turn on. So now this one will only run if we have oxygen on the input. It will only take in fuel if it has not just volatiles but oxygen as well, and it will only fill up the cooling tank to 1 liters. After that it will shut off, so the cooling should be a bit more efficient. Okay, quickly go outside and quickly close, don't vent too much hot stuff into the base, and that will do. Okay, and now we just need to have this one, and I believe this is the base analyzer. I guess we will see once we load the final code, but I do believe this is the base analyzer. Right, you can turn on. Okay, so we have these guys. I will quickly set up the housings. Okay, now we need the actual console parts. So for that one, we will need pretty much everything. So steel, we can stop outputting now, please. So steel, copper, we will need silicon for sure. I do believe we will need electrum and solder, although I'm not 100% sure, but I suspect we will. So we will need modular consoles. The base is we will need 6 of these. So let's set this to 6 and let's get started. After that, we will need, oh geez, a lot of stuff. Let me see. What do we need for the rest of them? Modular. We will need, okay, just a bit of extra iron and that's it. Okay, bring in the rest of the iron, please, which will be in here. Also, I am tempted to add one more thing to the counter script. Basically, if the printer is turned off or if it is not active, then we might want to tell the stackers to basically empty out. I think that would be kind of an okay addition. Anyways, iron goes in. So okay, we need 2 more, that's fine. After that, okay, that's 5, the 6th one is printing now. We will need inputs, so modular inputs. For this one, we need 7. Okay, so that's the 6, good. Now we need 7 of these. This one should be printing a bit faster. After that, oh geez, we need 34 displays. That's going to be a lot. In the meantime, we might as well set this one up. So, the base devices.
Health low.
I think this will do quite nicely. You can go right here. And I would like to have 3 vertical surfaces as well. Yes, these exactly. Okay, 3 of these and that will do. Okay, let's hook up to the power network. And don't forget to hook it up to the actual rest of the power network. Right, we cannot go through the door this way, I believe. So if I want to do this one, yeah, it will not work. Okay, that's fine. Right. Here we will go straight down and then curve into the power network this way. Yeah, that will do quite nicely. Okay, so this is good to go now. The inputs should be done by now. Yep, we have 7 modular inputs. Good, and now we need the displays. As I said, we need 34 of these. Let's get started. We should have plenty enough so we can get started. In the meantime, I will install the inputs. So we will need, let me see. We will need, right, 2 of these utility buttons here and here. And the rest of the inputs will be these logic switches, which will be here, 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 and here, and here. Right, so these are all the inputs. And I suppose we might as well start, yeah. Okay, so laptop out. We might as well start naming things. So this one import should be empty. Yes, it is. Good. The inputs are on the number 3 code, so might as well load it. Overwrite. And there it is. I will not run through the entire code piece by piece. What I will do instead is demonstrate the functioning once everything is set up. So, right, we need the volatile filtration switch. So I suppose we can override the code at this point. You can go back. So we need to name these, obviously. This is the volatile filtration switch. Good, it is turned off. Lovely, it is working so far. Then we need the combustor switch. Combustor switch, it is now okay. And we need the water filtration switch. Great. Oh, by the way, you guys should be on. We don't want to turn off the devices right now. So there. The next one will be the AC1 and then the AC2 switch. So this is the AC1 switch and this is the AC2 switch. By the way, this is going to be a big capital on and this is going to be a big capital off. I suppose we might as well color them. We should have the... Right, we do have the red one, but we don't have a green spray can. Okay, fine. Let me see. Don't we put everything in here? Yeah, I think so. Oh, never mind. We have some extra iron right here. So can you please give me some green spray? This one, just the one. And we need a red one as well. So green, you can turn off. And after this one, we'll go to the old base and eat and drink. So let me see. This one goes in here and make sure the pollutants dissipate before we do the other one. There we go. And now the red one and done. Okay. So that one should be fine. Let me quickly put these guys away and take care of our bodily needs. So there. And by the way, where are you? You are 33. Okay, never mind, you just finished. After this one, we might as well start printing out the labels. So labels, for this one, we need 32. There we go. Okay, and now quickly go before we die. Okay, so quickly eat, drink, and if we run out of potatoes, I will cook the next batch of French fries. Anyways, yes, we are good to go. Okay, then drink. Good, and I will harvest 3 potatoes. That's 4. Good, and we can cook the next batch of French fries. Lovely. So first 2 oil and then 3 more. 1, 2, 3 and then 3 potatoes. Very good. Okay, these guys can go here and you guys can cook. Excuse me. There we go. Okay, so we now have French fries once again. Might as well eat. That will put us up to 3 stars. Not quite 4 stars, but almost. 124. Lovely. Okay, should we take a shower? Yeah, might as well. Okay, that will do. By the way, how are we on charcoal? We have 3 still. Okay, this should be enough for a couple of extra showers, but we might want to do a bit of extra. Anyways, we are good now, so we can go back.
Oxygen low.
You know what? Yeah, let's just bring in 1 more canister of oxygen for the water generator. I want to test it once the whatchamacallit is finished. Once the console is finished, I want to see if it is actually working. So first, switch this one out. And then, yeah, this will be enough. It's fine. Oh yeah, by the way, almost forgot. We need to reset this one. So this one is set to 15. Yes, and I believe this was 15,000. Yeah. Although, no. This one should be... Yeah, you know what? 17.5 megapascals. Should be fine. I suppose I could check the code, but whatever. Also, we should bring down the rocket, but maybe at 25% is fine. Let's check on the plants first. I want to see what's going on with these guys. So, water-wise, they are fine. They still have 16 liters. What about you? Right. We can harvest seeds from these guys. Oh geez, that's going to be a lot. Okay, I'll just put this one here for now. We need to check back on them later because some of them are still seeding. So yeah, after that I will make a big harvest and let's see what we are dealing with. In the meantime, the printing should be finished by now, right? Let's check. So it is not running. We have 32 labels. Good. Okay. Oh, right. And I forgot. We have these. 2, 5, 4, whatever. It's fine. Eventually I will remember that we have those. So let's set up the labels first. That should make our lives a bit easier. Okay, I believe that's it for the labels at least. I suppose we might as well label them now. Okay, so all the labels are now labeled. Now we need the actual displays. first things first. You know what? Yeah, I will place down everything and then I will name them. And there we go. So this is going to be the main monitoring and control console for the water generator. Let me see. So this side is good to go at this point, I believe. So we just need to reseat it. Oh, right, and we need to name these. Okay, let me see. I believe it is the same as these, just not switch but diode. So copy this one here, but it's going to be diode, I believe. Confirm, and there we go. Perfect. There we go. So this means that the respective device is currently idling. If I switch them off, then they will turn red, and if they are not idling but they are active, this one will turn green. Okay, and yeah, it will automatically turn this on, so there we go. These guys will be on no matter what. Next up, the power. I believe this is power draw. Yeah, there we go. But it should be yellow, so reseat the chip, and it's now yellow and it is displaying watts. Great. And as far as I can tell, this is also controlling the main switches or the buttons. So if I press this one, everything switches off. If I press this one, everything switches on. Lovely. Okay, so this chip is now complete. Next up, let's take care of the first one. So load the console1 script. And there we go. This will require a lot of renaming. Let's just get started on it. Let's see if I'm on the right track. So if I reseat this one, lovely, it is working. Oh, right, and we need to set up a couple of devices. At the start, yeah, it was too big of a code, so I was starting to use dedicated devices for the main devices, but it ended up being so big that, technically speaking, this is not necessary, but you know what, it's fine. Might as well use this. Anyways, so for that one, sorry, don't take off the jetpack. Take out the screwdriver, please. Turn off the device, and then we can start setting these devices. Okay, so the main devices are now named correctly because they have switched off after, these guys have switched off. So we can close this one. If I turn everything back on, yeah, this tells me that the ACs are active, but everything else is inactive. Exactly. Okay then, so let's set the devices for real this time. Alright, we have two active vents right now. We need to differentiate between the two, so we need to have... technically speaking, we only need to name one of them. So this is going to be the... external intake vent. Does not matter. Just need to make sure that we know which is which. Okay, apparently I had a small bug in the code, but doesn't matter, it will do the job. So that will do. And if I let this one go, there, it is now reading the correct numbers. Very good. Okay, let's continue with the naming. Okay, now it should be done. So if I reseed the chip, now we are reading everything correctly. We have the correct values, we have the correct units and all that. Okay, good. I will run through everything at the very end. Is the vent active? Yeah, I think it's on the second one. Okay, speaking of the second one, let's load the next batch of the code. Okay, theoretically the devices have been set correctly now. Good, and now we can start naming. And by the way, this one should be the... I guess we will get to it once we get to it. And there we go. I believe this is now completely operational. We just need to reseat this chip. And yeah, everything is working as intended. Okay, let me see. So, these guys are the master switches for the different devices. So if I want to turn off the combustor, we can do so here. These diodes will turn yellow if they are idle, green if they are active, and red if they are completely off. So there it is. We have a main power draw display right here, and we can turn everything on and off with these buttons, as I have demonstrated already. So here we have the external intake. This is basically this tank right here. It displays the temperature and the pressure, and if the outside vent is active, this one will be displayed with this diode. If it turns green, then we are venting in outside gases. And then we are monitoring the temperature and the pressure on the voltage tank, the same on the oxygen tank, which I will switch out in a second, so we can actually check if it's working. And then we have the fuel tank. It is displaying the temperature and the pressure, and it is also displaying the amount of moles of voltage and oxygen and their respective percentages. We have 70% voltage and 30% oxygen, as it should be. And we also have these sliders here. Basically, this will display how much we are intaking right now. So if we take in a little bit of voltage, it will be a single bar of red right here. If we are going full blast, it will be a full bar of red, and the same goes for the oxygen. Speaking of, I suppose, if I remember correctly, yeah, this one is set to 5 liters. I mean, we only fill it up to 200 moles, so I think 5 is just fine. And then here we have the combustor output, temperature, the pressure, and we can also read how much water or steam we have on the combustor output, the amount of moles, and how much of the entire contents is actually steam. It is 30%. And then we have the steam cooler tank. Basically, the water pipes behind this pump. Here we have a bunch of steam that is way too hot, but it is slowly condensing out. Right, and then this one gets dumped into the water cooler tank. Basically everything... Oh wait, sorry. The steam is those pipes, and this is the water cooler tank. My bad. So, in the water cooler tank we have a tiny bit of liquid water. That is because it is currently daytime, so we are not cooling all that much. But anyways, it is very hot, and it is not a lot. But as soon as the outside temperatures are permitting, this one will start filling up quite nicely. And we are monitoring the temperatures of the first AC unit and the second AC unit, and then we are monitoring the temperatures of the water inside the base tanks. And also we have this one here. If you remember, we are equalizing the temperatures between the main radiators and the steam coolers if the steam is hotter than the outside, which it is not right now, so this one is off. Good. If it is start equalizing, it will turn green. And I think that's going to be pretty much it for this one. So, right, as I said, this one should be working quite alright at this point. I will wait until nighttime before we test this out. In the meantime, let's just go back to the old base and maybe cool down the rocket, but definitely we need to eat and drink. Okay, welcome back. Let me quickly eat some French fries. This one should put us up to 4 stars at this point. There we go, we have 4 stars, and drink. Oh, by the way, the combustor is off. That little red switch is red. And if we drink, it should turn green. Because we will deplete enough water. And it's still red. Why? We have 18 liters in the base, so it should be turning... Oh, that one is... Why are you complaining? That's not good. Oh jeez. Things are creaking. Import. Okay, line 23, edit and pause. So line 23, load the water ratio from the water analyzer, volume of liquid. If it is 1 liter... What? Oh, wait. We have more than... No, wait. We have a dedicated water analyzer. Yeah, there it is. Device not found. Okay, quickly vent off the access. Thank you. Okay, so apparently it lost... Oh, that's not good. That's why. What happened? Okay, just for now. We can pick this one up. And replace this one. We need some water piping real quick. How did that happen? It really shouldn't have. Thankfully now we have another source of water, so it's not the end of the world. But still, it's a bit of a mystery. Okay, quickly give me, I don't know, 10 insulated piping. So insulated pipes, we need steel and silicon. Okay, what happened again? Let me see. We have that one. Okay, it's not the end of the world now. It's fine. Let me just quickly switch the combustor off. There we go, so we are... Alright. I suppose, you know what? Yeah, let's just switch everything off. Let me see. Can I reach it? I think it's off now, yeah? Yeah, okay. How did this happen? It really shouldn't have. Ah. Interesting. Okay, I will pick up one of these, it's fine. I'm not going to lose anything important if we don't have this one here. Okay, now we should be able to put everything back as they were. Yes, I know I'm doing it through the window, this is just time saving. So let's take a look. And this one is empty again. I think I will put the nuclear battery into this one now. And I will just print out one more. So you switch out the nuclear battery, please. Thank you. And let's take a look at this. So this one is high pressure, obviously, and it is cooling. So I suspect it had liquid inside, but it should have been dumped into this one. Just like this. Anyways, at this point we are back to normal. Now we need one more liquid analyzer right here. Oh, I suspect I know what the deal is. Let me guess. Am I batch reading from the liquid analyzers? Let's take a look. Import this one. So am I batch reading from liquid analyzer? No, I'm only batch reading from the internal liquid analyzer. Everything else is through a dedicated device. So it wasn't that. I have no idea. Okay, anyways, we have plenty of water in this base, so I will switch this one off for now. And I suppose I will troubleshoot it at some point. Although I should switch it off at daytime. No, let's just bring in another analyzer, it's better that way. And we are way over time at this point, so it's far from ideal. Okay, let me quickly take a look at the plans and then we'll install this. And after that, I suppose in between episodes I will try to troubleshoot what happened with this whole setup. Okay, we have 48 soybeans. That will be quite a bit of extra oil. Let me quickly install this analyzer, turn these into oil, and I suppose then we can say goodbye. Okay, theoretically, now we are back to normal, apart from the fact that I have no idea why this happened. Everything else is okay at this point. So yeah, in between episodes I will try to troubleshoot what went wrong. I don't really know right now. I guess we will find out. For now, let's just turn these soybeans into water, or sorry, oil. That will do. And you know what? Yeah, let's just bring down the rocket now. So, map, you come down to the launch pad. Off you go. That will do. And before I forget, yes, we need to replace the power umbilical because I forgot to retract it and it burned out. Oh well. So, I will try to figure out what went wrong. I guess we will see. Thankfully we have plenty of water still, so it's fine. But still, not ideal. Okay then, so for now, all that is left to say is that thank you for watching. If you like the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.